Right. Good morning, all of you. Last class we are in concentration terms. In that we completed mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, relation between molality and mole fraction of solute, and last one right heading relation between right today's date. Right heading relation between molarity, that is capital M, molality small m, and density. So there is a relation between molarity and density. Important. Make a note. What is that relation? See, this molality is given by 1000 into molarity by 1000 into density minus molarity into molar mass. This is the relation between molarity and density. Write this relation. So in the problem they give you molarity to you, density they give you, and they ask you to find molality, and this is molarity into molar mass of the substance. Copy this. Capital M is molarity, small d is density, this capital M is molarity. So this is important, students. So relation between molarity and density. Copied all of you. Clear. Right, today's date. This is the last concentration term in the bridge course we are having. Now write one question related on this. Concentrated sulfuric acid having 18 molar, its molarity is 18 molar, and its density is 1.8 gram per cc. Then find its molality. Now see, in the question, molarity given to you 18 molar, density given 1.8 gram per cc, asking to find molality. So this is what relation between molarity and density. Now what is that relation we wrote just now? Molality is equal to 1000 into capital M. So molarity we have to find. Molarity given to us 18 by 1000 into density. Density of sulfuric acid given 1.8 minus molarity is 18 and molar mass of sulfuric acid. What is the molar mass of sulfuric acid? 98. Algebraic sum of atomic mass that you are familiar, 98. Now this comes how much? Molality is equal to 18 into 1000 comes 18,000. Correct? 18,000 by, this is 1.8 into 1000. So 10 get reduced, which comes 1800. 1800 minus, multiply 18 with 98 in the rough work. Everyone do this calculation. 18 98s are 8 8s are 64. 1 8s are 8. That comes 14. 8 9s are 72. 1 9s are 9 plus 6 16. 4 6 1764. Is it coming 1764? Check. This is 1764. Take all of this, 1764 I am getting. Now subtract from 1800 1764. From 1800 1764, when you subtract 10 minus 4 6, 9 minus 6 3. Is it coming 36? So this denominator value I am getting 36. So that comes molality is equal to 18,000 by 36, and 18 can cancel 36 by 2 times, correct? 18, this comes 1000 by 2. So 2 will cancel 1000 by 500 times. So final answer will be 500 molal. This should be the answer, 500 molal. Understood? This is relation between molarity and density. So copy this, answer comes 500 molal. Clear, followed everyone? Now see, without formula, think over, we don't know about the formula. Now think 18m means, what does it mean? 18m means 18 moles is present in 1 liter of solution, no? Molarity means what we learned, student. 18m means 18 moles is present in how many ml of solution? 1000 ml of solution, no? Correct. Now see, density given, but actually molality, to get what we want, mass of solvent we want. I write it in next page. Copied all of this. Copied them all of. Now see, I write it in next page. Now we don't know about the formula. What does 18m mean? 18m sulfuric acid, what does it mean? 18 mole sulfuric acid is present in 1000 cc, no, 1000 milliliter of solution. Correct? Do you agree? 18 molar means 18 moles of sulfuric acid is present in 1000 cc. Now density is given. Density can be taken mass by volume. Density of the sulfuric acid given 1.8, and mass of solution we have to find, because we don't know that. Volume of the solution we know as 1000. So here put 1000. Then what will be mass of solution? Mass of solution comes 1.8 into 1000, no? That comes 1800 grams. But student, we want mass of solvent, no? Molality to get what we require, mass of solvent we want. So mass of solvent to get what minus what from solution mass, this is 1800. You have to subtract the mass of solute. This is solute, no? Sulfuric acid is the solute. 1 mole sulfuric acid weighs how many grams? 98 grams. So for 18 moles, what will be the mass? To bring moles in mass, what you do? Mole concept. Moles you multiply with molar mass. That means 18 of 98. The same thing what we got just now on multiplication. 17 18 98 we wrote just now. 8 8s are 64. 1 8s are 8. 14. 72. 16. That how much we got? 1764 we got. This 1764 on subtracting we got 36 grams. This is what mass of solvent. Understood. Then what is molality? We learned molality is number of moles present in weight of solvent in kg, no? Solvent in kg. So moles, how many moles we got here? 18. 18 by weight of solvent. This is weight of solvent in 36 grams it is. So this 36 grams we have to convert in kilogram. 36 gets divided with 1000. So this 18,000 by 36, see, this 18 will cancel by 2 times and this 2 will cancel 1000 by 500. See, without formula knowing, you have to think over. This is how we got molality, the same answer 500 m we got. Understood? Or you can direct apply the relation 1000 into molarity by 1000 into density minus molarity into molar mass. Understood, student? Copy this. The density given means something to do with density. Density of 1.8, mass of solution we are finding. So mass of solution is coming 1800. But to get mass of solvent, what we do? From 1800, you have to subtract the mass of solute. Solute mass is 18 moles. As you know, mole concept, 1 mole of sulfuric acid weighs 19 grams. So 18 moles will weigh how many grams? 18 into 98, that is 1764. Subtracting from 1800, we get 36 grams of what it is? Solvent. Now we substitute in the molality. Molarity is number of moles is 18. 18 by 36 is present in grams. We have to convert in kg. So 36 by 1000, 1000 goes to numerator. Final answer comes 500 m. So with this concentration terms has been completed. First we in bridge course I taught you mole concept, that is done, and I told you to work questions from physics wala, that is bridge course material. Now we start with another concept, acid, bases and salts. Right heading the last but third part, acids, bases and salts. Copied all of you this? Copy it first. Now we go for next concept, right heading, acids, bases and salts. Later when we start into the topic, we have one chapter called ionic equilibrium. In the first year we have a topic, ionic equilibrium, weightage chapter in JEE mains and NEET. So more questions we get numericals from structure of atom, periodic table, chemical bonding. These are all physical part. Ionic equilibrium, redox. Right heading, acid, bases and salts. Now see, in 10th class you may have idea what is acid, what is base, what is salt. No? So do you have in 10th standard students what is acid? So later when you do practicals in second year, you will physically see acid. Acid, how it will be physically, it will be colorless, just like water. But how we know it is acid or not means in the lab there will be a litmus paper. In the litmus paper, when you put in acid, if it turns blue litmus to red, the litmus paper will be blue. When you put it in acid, if it turns what? Red, it is called acid. So here make a note, characteristics of acid. How we know it is acid or not? In 10th standard you may have no characteristics of acid. Acid will turn what litmus to what? It turns blue litmus to red. Blue litmus paper will be there in the lab. You will do practicals in second year. And if you see the taste of acid, acid will be sour to taste. Dilute acid you can taste it, it will be sour. So it is sour to taste. Sour to taste. And you know in 10th standard you may know neutralization reaction. Acid can react with what? Base to form salt and water, and that process is called neutralization. That we study later in 11th standard thermodynamics. So what acid do? Acid can react with base to form what, student? Salt. And what is that process we call a neutralization process. Might we heard this in 10th standard, no? So for this you take HCl. What is HCl, student? Hydrochloric acid. Now this HCl I am treating with caustic soda. What is caustic soda? NaOH. Now HCl is acid, NaOH is base. So what happens, see, this is acid, no? This NaOH is base. Acid reacts with base to form water, salt and water. Now what is that salt? We get sodium chloride plus water. And this is what we are getting, salt, and this process we are calling neutralization. So these are the three characteristics of acid we see in the lab. It is sour to taste, it turns blue litmus to red litmus, it will react with base to form salt and water. Copy it. Then can you give examples for acids? What are the acids? One we are having hydrochloric acid. You know HCl. It is secreted in even in our stomach. Gastric juice. Gastric juice contains what? Hydrochloric acid for the digestion of the food we eat. And you know sulfuric acid is called king of chemicals. What is the formula of sulfuric acid? H2SO4. And you know nitric acid. Nitric acid formula is what? HNO3. And you know hydrochloric acid. What is the formula? Sorry, hydrobromic acid. HBr. Hydroiodic acid. HI. And perchloric acid. These are all strong acids we call. Only 6 acids are strong acids. What are those? Hydrochloric acid, sulfuric acid, nitric acid, hydrogen bromide, hydrogen iodide, and perchloric acid. Rest of all acids are to be taken as weak acid, like organic acid. Understood, Amma? These are all strong acids. Only 6 acids are to be strong. Rest of all organic acid like acetic acid, formic acid, phosphoric acid, what is the remaining acids are all comes under weak acid. And you know the in our daily life we see lemon fruit will have what? A citric acid. Lemon fruit will have what? A citric acid. And you know tamarind contains a tartaric acid. Later you study in organic chemistry. Tamarind will have tartaric acid. And in our gastric juice contain hydrochloric acid. So copy this. These are the some acids we observe in daily life. Lemon juice, citric acid. Tamarind will have tartaric acid. Gastric juice will have hydrochloric acid. And oranges will have or ascorbic acid. Understood, students? So acids characteristics understood. No, simple. It is sour to taste. They turn blue litmus to red. They will react with base to form salt and water. And based on the ionization of acid, we divide the acids into strong acid, weak acid. Strong acid means what? They will completely ionize. That means even at moderate concentration, they completely ionize. Like what? HCl, sulfuric acid, nitric acid, hydrobromic acid, hydroiodic acid. This acid is called perchloric acid. These are all strong acids. Now, what are weak acids? Then there are weak acids like acetic acid. Students should know who is weak acid means acetic acid. And you know rotten egg smelling gas. It will have the smell of rotten egg, hydrogen sulfide. I will have HCN, hydrogen cyanide, phosphoric acid, and you know oxalic acid. Oxalic acid is H2C2O4. These are all what remaining all acids are weak acids. So on what basis we say strong and what basis we say weak means there will be one value called Ka, dissociation constant. That means in case of strong acid, dissociation constant for acid will be very high. And in what case we call this as weak acid means if dissociation constant of acid is low. What is the dissociation constant means? It completely ionizes in case of strong acid. Weak acid won't ionize completely. They feebly ionize. So based on that, we are dividing the acids into strong and weak. Clear, students? Understood. Now we go for base, right? Base, right? Copied all of you. Next, right? Base. Now, what is base, student? How you recognize base in lab? Same way here also we have to study characteristics of base. Now, as I told you, there will be a litmus paper, no? As it is colorless, we don't know. Both acid will be colorless, base will be colorless. So we don't know who is acid, who is base in the lab. Then what we do, we take litmus paper. Previously acid, what the paper we took, blue we took. Now red litmus paper, when I dip it in base, if it turns red to blue, it is called base. So here right, it turns blue litmus paper to red. Sorry, red litmus to blue. Red litmus paper to blue litmus. And when you see the taste of base, that is dilute base, it will be bitter to taste. Whereas acid will be sour to taste, right? It is bitter to taste. And same as acid, how it is reacting with base. Base can react with whom? Acid. Same process, neutralization. So base, what it does, just like acid, base reacts with acid to form what and water? Salt and water. And what is that process we are calling? Neutralization. Same as in acid. So example, I am taking caustic soda. No, caustic soda is what? Base. This is base. Same previous one what I am writing. But now I am reacting with HCl. HCl is what, student? Acid. So simple, it will form salt. What is that salt? Previously what we wrote? NaCl is the salt plus water. And this process we are calling it as neutralization. So these are the characteristics of base. Simple. So base will be colorless, same as acid. So in the lab, to detect base, what we do? We take red litmus paper. If it turns red litmus to blue, we say it is base. And if you see the taste of dilute base, it will be bitter to taste, same as acid. It reacts with the base, same as acid. Base will react with acid to form salt and water, and that process is called neutralization. Copy this. And same as acid, how we categorize strong acid, weak acid. These bases are also categorized into two categories: strong base, weak base. On what criteria? As I told you in acid, Ka we wrote, no? Here it will be Kb. What is Kb? Dissociation constant for base. So here I am writing strong base. So students should have an idea of who is to be strong base, who is to be weak base. So strong base means when do we call whose dissociation constant? That is we show with Kb, whereas in acid we have shown with Ka, will be very high. Like you remember in a periodic table you study later, all 1A group hydroxide, so called sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, as well as 2A group elements. You might be know in a periodic table, second A, that is on extreme uh, left side it will be like barium hydroxide, magnesium hydroxide, Slackle lime. What is Slackle lime? Calcium hydroxide, strontium hydroxide. These are all what bases, students? They are strong bases. Why? Because they completely ionize. Whose Kb value? What is Kb? Dissociation constant for base. And this value will be very high for strong base. So students should have idea. Later we study in the main chapter when from 1st June onwards equilibrium chapter comes. Once again we recap all this. As it is bridge course, only on the basic level we are discussing. So this is strong base. Now coming to weak base. When do we call weak base means just like see Kb value will be low. What is Kb? Dissociation constant for base is low. Like ammonium hydroxide. You know what is the formula of ammonium hydroxide? NH4OH. And you know cupric hydroxide, CuOH taken twice. Ferrous hydroxide, FeOH taken twice. Aluminum hydroxide, AlOH taken thrice. These are all what weak bases. Why? Because their dissociation constant is very low. So this is what about base. Copy this. Next we go for salt. So this is acid base phenol. Now right next is salt, right? It is the third category, salt. Now what is salt? What we define for salt, student? A salt is formed by, how salt is formed by neutralization of acid and base, no? So right, that salt is formed by, it is formed by neutralization of acid with base, no? So how salt will be formed, student? Salt will be formed when acid reacts with base, no? The same thing we wrote. And you have to recognize what are the various salts we have. See, I am writing examples. Can you give? NaCl. Check, NaCl is been formed between what? NaOH and HCl, no? And I take NaNO3. It is salt, sodium nitrate. It is formed between NaOH and HNO3 and Na2SO4. Correct. This is salt formed between NaOH and sulfuric acid. NaClO4. It is a salt formed between NaOH and HClO4. Like KCl. This is obtained from KOH and HCl. KNO3. Same thing. KOH and HNO3. K2SO4. KClO4. Understood? So simple. A salt will be formed between base reacts with acid. So these are all what students solve. And keep it in mind, all salts are strong electrolytes. Whenever salt comes, all salts are strong electrolyte. What is meant by strong electrolyte? They completely ionize when we put it in water. All salts are strong electrolytes. So this is what the basic idea students should have, whom should we call acid, whom we call base, whom we call a salt. The same concept we study in the chapter called ionic equilibrium. And in the JEE mains weightage chapter, even in NEET also, more questions we get from ionic equilibrium, thermodynamics, physical topics is all. Completed. Now next we have to discuss theories of acids and bases, right? Subheading theories of acids and bases, right? Theories of acids and bases. Now there are some theories were proposed in order to explain the property of acid and base. So there are three theories in our syllabus. Might be heard this in lower class also. Arrhenius theory. What is the first theory, student? Arrhenius. Spelling Arrhenius. Arrhenius acid-base theory. This is the first theory. Later this theory was disproved by later another scientist came, Bronsted-Lowry theory. This is Arrhenius acid-base theory. The second theory is Bronsted, spelling Bronsted. Bronsted-Lowry, Lowry, Lowry acid-base theory. This is the second theory, important. Bronsted-Lowry acid-base theory. The third theory we are having, that is Lewis acid-base theory, because some of the drawbacks has been explained by Lewis theory. So the third theory, important theory, later we study in the equilibrium chapter, Lewis acid-base theory. So total how many theories are there, students? These three theories we have to discuss. Arrhenius acid base, that means which one we call Arrhenius acid, whom we call Arrhenius base, and whom we call Bronsted acid, whom we call Bronsted base, whom we call Lewis acid, whom we call Lewis base, that we discuss in the coming chapter. Now write heading, copy all this, and we discuss one by one these theories and what are the drawbacks. Following all of you. Now we start with Arrhenius acid base theory. Right, first theory, Arrhenius acid base theory. Now in this case, student, we have to know whom we call Arrhenius acid. Now see up there, Arrhenius acid. Now which one do we call Arrhenius acid? Means simple, substances which increases the concentration of hydronium ion. What is hydronium ion? H3O plus in aqueous medium. Aqueous means what? Water. That means this theory is applicable only if water is present. So understood what I am saying? Arrhenius acid, when do we call? Substances which increases the concentration of hydronium ion. What is hydronium ion? See, hydronium ion is shown by the symbol H3O plus. This is called hydronium ion. What is this ion called? Hydronium ion. That means when you place it in water, if they are increasing the hydronium ion concentration, actually H plus ion will be produced, but this H plus ion is not stable. So what happens, this will combine with water molecule. Later you study chemical bonding, dative bond, coordinate covalent bond will be formed. This will accept the proton and it will convert into hydronium ion, and this ion is called, what is the name of this ion? Hydronium ion. Are you following? So simple, first acid, you know, no, in lower class 10th standard, acid will furnish H plus ion. So the H plus ion is not stable. So what that H plus ion do, it will combine with water and it will form hydronium ion. So substances which increases the concentration of hydronium ion in water, such substances what we call Arrhenius acid. So write definition, substances which increases the concentration of hydronium ion, H3O plus. In what medium, student? Aqueous medium. What is aqueous means? Water. That means this theory, if water is not there, this theory couldn't tell who is acid, who is base. So this is one of the limitations. Only in water medium only this theory has taught who is acid, who is base. So understood, simple, no? So substances that increases the concentration of hydronium ion. What is hydronium ion? H3O plus in aqueous medium is called areninous acid. Then can you give examples for areninous acid? The examples are, I am writing what are the examples. Can you tell student? HCl, H2SO4, HNO3, HClO4. The compounds whom else they have H, you can consider as areninous acid, no? So whom else they have H, they will furnish H plus ion, no students? Like acetic acid, like HCN, like H2S. So these are all what areninous acid. Why they are increasing the concentration of what ion? Hydronium ion in aqueous medium. Simple understood. So simple one word what you have to remember areninous acid comes hydronium ion concentration if it is increasing it is areninous acid. Clear? Now write areninous base. Copied all of it. So whom else they have H they all comes under areninous acid like HCl, H2SO4, HNO3, HClO4, acetic acid, H2S, carbonic acid. All H containing acids comes under areninous acid. Understood that? Now write areninous base. So next the areninous base. Now when do we call a base as areninous? Means simple. Substances which increases the concentration of hydroxyl ion. If you place substances in water medium, if they are giving more number of OH minus ion, no base, no base, what they do, they will furnish OH minus ion. So substances that increases the concentration of hydroxyl ion. What is this ion called? Hydroxyl. Hydroxyl ion. So what we define for areninous base? Substances which increases the concentration of hydroxyl ion. What is hydroxyl, students? Hydroxyl is shown by the symbol OH minus. In what medium, students? Only in aqueous medium. No, I told you this theory is applicable only in aqueous medium. In aqueous medium. Such substances what we call a areninous base. Simple. So if they are giving OH minus ion in aqueous medium, we call it as areninous base. If the substances are giving H plus ion in water, those are called areninous acid. Simple. Now what are the examples can we quote for areninous base? Now can you tell student what examples we can write? See, we can write examples of caustic soda. What is caustic soda? NaOH. Caustic potash. All substances whom else they have OH, you can give examples like cesium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, etc. These are all what the substances which increases the concentration of OH minus ion. Understood simple, no? So got idea whom should we call areninous acid, whom we call areninous base, simple. If substances increases hydronium ion, it is called areninous acid. If substances increases hydroxyl ion, we call areninous base. And write limitation of Arrhenius theory. Now what is the limitation of this theory? See, regarding limitation, see, this theory is applicable only in aqueous medium, means If water is not there, we cannot tell who is acid, who is base. So is it limitation or not? Right there. This theory is applicable only in aqueous medium. Here, right, it is applicable only in aqueous medium. What is aqueous, students? Aqueous means water. So other than water, this theory couldn't told who is acid, who is base. It is Arrhenius theory done. Now write Bronsted-Lowry acid-base theory. Hope all of you understood. No, simple. What is Arrhenius acid? What is Arrhenius base? Next, we have to discuss Bronsted-Lowry acid-base theory. We are heading Bronsted, spelling B-R-O-N-S-T-E-D. Bronsted-Lowry, L-O-W-R-Y, Lowry acid-base theory. Now, in this, we have to discuss same as in Arrhenius acid, whom we call Bronsted acid, whom we call Bronsted base. Now, observe here. Let us take Bronsted acid. Simple one word what we say for Bronsted acid. Bronsted acid is nothing but substances that donate proton, or simple one word we say proton donor. In the previous Arrhenius acid also same thing, but there what we took water, no hydronium ion. So here also substances which donate proton are called what? Bronsted acid, or simply one word what we say proton donor. Here write proton donor, the one that donates proton. Understood? Whom else they give proton, they are called as what? Bronsted acid. Same examples what we took in Arrhenius. Can you give examples, students? What are the examples we can give? See, examples of all H substances: hydrochloric acid, hydrobromic acid, sulfuric acid, nitric acid, acetic acid, perchloric acid, etc. These are all what, students? They are Bronsted acid. Why? Because they can donate proton. Proton donor are all called Bronsted acid. And even water acts as acid and base. So simple one word, no? One word what we say proton donor. Substances that donate proton. Next we have to discuss what is Bronsted base. So write Bronsted base. Okay, Bronsted base. One word what we say for Bronsted base. Proton acceptor. See, correlate in Arrhenius theory, what we wrote Bronsted base means the one that donates OH minus. Here, proton acceptor, the one that accepts a proton. So, simple one word what we define for Bronsted base, proton acceptor. That means substances that accepts proton from another substance is called proton. Proton acceptor is called Bronsted acid. Sorry, Bronsted base. I wrote here acid, it Bronsted base. Understood? Single one word. Then what are the examples, student? You take counterpart. Counterpart means you remove H from it. When you remove H from this, what should I write? Tell me. Cl minus. Counter ion of all these you take. Counter ion means remove H. Cl minus. Remove H from HBr. Br minus. Remove one H from H2SO4. HSO4 minus. Remove one H from HNO3, NO3 minus. Remove one H from acetic acid, CH3COO minus. Remove one H from HClO4, ClO4 minus. Remove one H from water, OH minus. These are all what students? Proton. What they do? Proton accept because they are rich. No, see, negative charge is rich. No, so they can accept the proton. The counterpart of all strong Bronsted acid can act as Bronsted base. Getting idea? All of you saw the difference between Bronsted acid and Bronsted base. Clear understood, students? Bronsted acid means proton donor. Bronsted base means proton acceptor. Copied all of you. Now see, let us take example. Write one equation: HCl plus water. Copied them all of you. Now see, next write this equation: HCl. What is HCl? Hydrochloric acid. You react with water. Now see, in this tell me student, HCl and water, who will behave as acid, who will behave as base? This is acid, no? HCl act as acid whereas water act as base. Correct? So this will be acid, this will be base. Now tell me acid what it does according to Bronsted acid, what we learned, proton donor, no? So this will donate proton to this. Then what happens is this will convert into Cl minus. As one H is donated to this, no? So that becomes Cl minus, and it has accepted a proton by having a lone pair later in chemical bonding you study. So that will be converting into hydronium ion. See, hydronium ion. So and this process is called neutralization. No? Right here, neutralization. Neutralization. Now you come reverse direction. Reverse means see backward you come. Now in the backward, see previously this is acid one I am writing, this is base one. Now in the reverse reaction, see who will act as acid. This can donate proton to this, no? This will be acid 2. Getting idea what I am saying? This is acid and this is what this is accepting proton in reverse direction. So this will act as base. I call this as acid 1, base 1, and this I am calling as acid 2, base 2. Understood? Now we are getting a new word. What is that? Conjugate acid base pair. So last point, see conjugate acid base pair. Now what is conjugate acid base pair means? An acid base pair that differ by one proton. What is conjugate acid base pair? Important in exam they ask you. An acid base pair that differ by how many proton? That differ by one proton. That differ by one proton. If they are differing by one proton, we call it as what? Conjugate acid base pair. Now see in this, these two are conjugate acid base pair, and these two are conjugate acid base pair that are differing by how many protons? One proton, no? Are you getting idea? These HCl and Cl minus, they are conjugate acid base pair. Why? Because they are differing by one proton. And H2O hydronium ion are conjugate acid base pair. So here student, what you have to keep it in mind in exam point of view, to get conjugate base from conjugate acid. If you want to bring conjugate base from conjugate acid, remove H. Then you get conjugate base. If you want conjugate acid from conjugate base, add H. So in exam they ask you conjugate base, conjugate acid, this relation you have to remember. Understood. Conjugate base to get from acid, what you do? Remove H. Conjugate acid to get from conjugate base, what you do? Add H. We discuss this in tomorrow. I give you tomorrow few examples of conjugate acid, and I will ask you what will be the conjugate acid, what will be the conjugate base. We do that in tomorrow's session. After that, we go into pH concept. Hope all of you are following, everyone. So we will stop here. We will conclude here. Copy this. This is important. Conjugate acid base. It's understood. No? Conjugate acid base pair is nothing but the one that differ by one proton. The difference should be only one proton. So in order to get conjugate base, remove H. In order to get conjugate acid from conjugate base, add H. So we stop here. Wish you all the best. And I told you, no, practice all this. Recap all the concepts in the class what we are teaching. Okay, right, by ending the session.